Hello everyone, I hope you all are great. Welcome to another exciting tutorial on graphs in practical situation. In this particular video, we will be discussing distance time graph and solving questions. So let's begin. Okay, so in the first part of this video, I'll be discussing about distance time graph. If you haven't seen my previous videos on the various types of graphs and calculating stuff from the graphs, I'll recommend you to watch that video first and then come back to this video. So in a distance time graph, when a distance time graph has been given to you, remember this, that the gradient of the distance time graph represents speed. So if you have a steeper line that has a positive gradient, and since this is a straight steeper line, it will have a constant gradient. So that constant gradient will represent constant speed. If you have a horizontal line, so we know from the previous exercises that horizontal line has zero gradient. So any line that has a zero gradient is always horizontal, and since in a distance time graph the gradient represents speed, so the speed would be zero. Since the gradient is zero at this point, so the speed would be zero. This section is also representing a constant speed, but if it might be more steeper than this. Now here we have another straight line, another steeper line, but this has a negative gradient because it has a downward slope. But the gradient, if you try to calculate the gradient between these 2 points, it will be a constant value. Now since it has a negative gradient, the value of the negative gradient represents negative speed. Now negative speed means that if the particle was at here, if any body was at this distance, so it is coming back to its own home ground. It is coming back to the starting position. So I'll quickly revisit this distance time graph. In this distance time graph, the gradient represents the speed. So if a line has a constant gradient, that represents constant speed. If a horizontal line is there, which means that the speed is zero, and if there is a negative gradient, this means that the particle is coming back with the constant speed, but the speed is in the opposite direction. Now what if you do not have a constant line? Then you will have a curve. So if you don't have constant speed, or the car wasn't traveling with a constant speed, there are two scenarios. Either the car is accelerating or it is decelerating. So if the car is accelerating, the speed is going to increase. So here you have a curve up, because if you try to draw tangent at different points, the gradient of the tangent will always be increasing. So this section represents increasing speed, and this section represents decreasing speed. Okay, so decreasing speed doesn't mean that the distance is decreasing. It just means that the car is covering the distance at a slower rate every time. So this section is for decreasing speed. So let's understand the distance time graph through an example. In this question, the question says that the distance time graph shows Ravi's cycle's journey. He sets out from home and cycles to a park. After a short stop at the park, he then continues his journey to a shopping center. He stops for lunch at the shopping center before cycling home. So before doing all these questions, let's try to understand what the graph is telling you. He starts from home, okay, and he cycles to a park. So he reaches the park over here, where he takes a short stop, and after stopping for some time, he starts his journey towards the shopping mall. He spent some time at the shopping mall. So you can see over here then that while he was in park and he stopped, he is not covering any distance, which means the speed was zero, and the time is actually running out, but he is not covering any distance, which means speed was zero. Similarly, when he was shopping center, he was having a rest over there, he was having a stop for lunch at the shopping center. The time is running, but he is not covering any further distance, which means his speed was zero at this point. And then he is coming back from the shopping mall back to his home. So this is the graph that has been provided to you. You are in part 1, you are being asked at what time does Ravi arrive at the park. So He arrives at the park. So he arrives at the park at this time. So simply the answer to part 1 would be 11:30. Now this is a distance time graph in which the distance is in kilometer and time. Well, time is represented over here, but you will be taking it in terms of hours. Now now in part B, the question says how many minutes does Ravi spend at the shopping center. So in order to find how much minutes he has spent, we'll have to see at what time he reaches the shopping center and at what time does he leaves the shopping center. So he reaches the shopping center at this particular time, okay, and he leaves the shopping center at this time. Now you have to be careful in reading the graph, reading the values from the graph. So if from 12:30 to 13 it's half an hour, and half an hour is divided into small 10 blocks. So each block represent 3 minutes. So if you have two blocks over here, this means that this time is 12:36, okay, and this time over here is 13:15. Now the question is how many minutes does he spend at the shopping mall. So you have to look at the time difference. So from 12:36 to 13, from 12:36 to 13:15, if you count the number of minutes, you will get 39 minutes. That's the answer for part B. In part C, they are asking how far is the park from the shopping center. Now when they ask how far is the park from the shopping center, you will look at the y-axis, which is the distance axis. So the park is situated at 10 kilometer at a distance of 10 kilometer from his house, and the shopping mall is situated at a distance of, you can read the values from the graph. So this value is 18. So I can say that in part C, the distance between the shopping mall and the park is 18 minus 10, which is 8 kilometers. In part D, the question says, at what speed does Ravi cycle home? Give your answer in kilometer per hour. So let's look at the section that we are interested in. We want to find the speed when he is cycling back to home. So he goes from the shopping mall back to home following this path. So let's look at what his speed is. So he leaves the shopping mall at this time, and while he was at a distance of 18, and he is coming back at 14, and his distance from home would obviously be 0 because he has arrived at home. So basically you are being asked to calculate the speed at this instant. So speed, obviously since it has a downward slope, the speed would be negative, okay, but let's find out. So the speed, he has covered a distance of, so when he is back at home, you can just apply the gradient formula. When he is back at home, okay, so the distance is 0, initial distance was 18, and the total time that he takes from leaving shopping mall and arriving home is 45 minutes, okay, from 13:15 to 14, it's 45 minutes. Now since we want it in kilometer per hour, I have to convert 45 minutes into hours, and 45 minutes in hours would be 0.75 hours. You will divide 45 by 60 to get this value of 0.75 hours. So when you divide 18 minus 18 by 0.75, you get minus 24 kilometer per hour. But generally you will ignore the sign over here just because they have asked you speed. there is no concept of okay, so the question doesn't specify the direction. This minus sign is just telling you about the direction. Okay, so just the speed itself would be 24 kilometer per hour. You will have to drop the sign over here because they have asked about the speed, which is a scalar quantity, and we will not be giving any sign with we will not be associating any sign. Now for part E, they are asking between which two places did Ravi cycle slowest. Now obviously slowest, he will be cycling slowest where the speed would be low. So we have three regions. Okay, the first region was when he was cycling from home to the park, then from park to the shopping mall, and then this part he was cycling back from the shopping mall to home. Now if you closely observe, the one with the lowest gradient will be our answer. So let's look at the section where we have a lowest gradient. Over here, if you closely observe over here, the value is the value of the speed would be 10 over 0.5 because 30 minutes is 0.5 hours. So this comes out to be 20 kilometer per hour. Now obviously this section is less than this, and this value was 24 kilometer per hour. So obviously he takes the least time taken, or the region where he was moving slowest was from park to shopping mall. Fine. So at this region, this is the required region. At this region he was moving slowest. You can calculate the speed as well. It must be less than 20. In part F, guys, in part F you are being asked, Salim, who is Ravi's brother, sets out from home at 11:15. He cycles directly to a shopping center at a constant speed of 15 km per hour. Who arrives at the shopping center first? And how many minutes later does his brother arrive? So let's find. We know that Salim is starting his journey at 11:15, which means that he is starting his journey at 11:15 at this position, and he is traveling at a constant speed of 15 km per hour. So if I were to draw a line, I would have to draw a line with a gradient of 15. Now I can do it without drawing a line. I know that the speed of Salim is constant, so speed is basically distance over time. Since he is traveling with a constant speed of 15 km per hour, I already know the speed. I know that the distance from his home to the shopping mall is 18 kilometers. So let's find out how much time is Salim taking. So if you cross multiply and solve this equation, you get time to be equal to 1.2 hours. Now 1.2 hours is same as saying 1 hour, 1 complete hour, and 0.2 hour. For 0.2 hours you will multiply it by 60 and you will get 12 minutes. So 1.2 hours is same as saying 1 hour and 12 minutes. So once you have the time, you knew that Salim started at 11:15. Okay, and after 1 hour 12 minutes, he started at 11:15, and after the journey of 1 hour and 12 minutes, he will reach the shopping mall at 12:27. Okay, he will reach at 12:27. Now we need to compare his time of arrival at the shopping mall with his brother Ravi. So if you closely observe the graph, we will look at the time at which Ravi arrives the shopping mall is 12:36 and he is arriving at 12:27, which tells you that Salim reaches first. So in the first part of the question you were asked who arrives the shopping center first, you will say Salim. Salim reaches first. and in the later part you are being asked how many minutes later does his brother arrive. So you will take the difference of 12:27 and 12:36. So it's a difference of 9 minutes. So this was a question, this was an example question on distance time graph. So the next thing we would look at is the speed time graph. In a speed time graph, the values of speeds are plotted on the vertical axis and the time obviously is plotted on the horizontal axis. Now this is an example of a speed time graph, and let's try to understand what does this mean. On the contrary, like in the previous video we discussed distance time graph where the gradient represented speed. In a speed time graph, the gradient actually represents the acceleration, because speed per unit time is acceleration. So if you have similar concept, the gradient would represent, if you have a constant gradient, it will mean, now in this graph it would mean a constant acceleration. So if you have a positive gradient, that positive constant gradient which is represented by a upward slope line, this upward steeper line, this would mean that the car is moving with a constant acceleration. When you have a zero gradient in a speed time graph, zero gradient implies that the car is not accelerating. If the car is not accelerating, this means that the car is actually traveling with a constant speed. The car is still moving, but it is moving with a constant speed. So the car will not stop. This horizontal line does not mean that the car has stopped. It means that the car is moving with the constant speed. And while it is moving, it is obviously covering distance. This line with a negative slope is for deceleration. And this is same as saying when the car has applied brakes, the car will slow down, and slowing down means that its speed will continuously decrease, and since it's a straight line, the value of the gradient is constant. This means that the car decreases its speed constantly by the same value, hence constant deceleration. Now similarly, if you were asked to calculate constant acceleration between these 2 points, you would find the gradient between this point and this point. Now remember this, that in a straight line the value of acceleration will always be same. So even if you are asked to calculate gradient between these 2 points, or the same this point and this point, the gradient or the acceleration is actually the same, because a constant line will always have a constant gradient, which means a constant acceleration, or vice versa, constant deceleration. The gradient between these 2 points will give you the constant deceleration. Even the value would remain same if you were taking these 2 points. Okay, now what if the car was not moving with a constant acceleration or constant deceleration? There was an increase in acceleration every second. So it's same as saying you have applied the accelerator, you have applied your foot on the accelerator, and every time every second the car speed is increasing. So since we know that the speed time graph gradient gives you acceleration, and in case when you have curves on your graph, if you try to find tangent, if you try to draw tangent at particular points, the gradient of the tangent becomes steeper. If the gradient of the tangent becomes steeper, this means that in this curve you get increasing acceleration. So if you have a curve up, which is shown in over here, this curve up means in a speed time graph means that the car is moving with an increasing acceleration. And similarly, if there is a curve down, this means that the car is moving with a decreasing acceleration. Now decreasing acceleration also means that the car is moving, it will be covering distance, but it is not increasing the value of speed as it was used to be. Okay, now other thing that we have to learn from a speed time graph is to calculate the distance from a speed time graph. In a speed time graph, remember this, that the area under the speed time graph gives you the distance covered. So if I were to find the distance covered by this car, I will calculate the area under the speed time graph. Now you have to identify the shape which has been drawn. So I can easily spot on that this is a trapezium. Right now this is a trapezium. So if I apply the if I had values over here and I would have applied trapezium distance formula, that was half into sum of pedal size into height, I can easily calculate the distance traveled by the car. Or what you could have also done is you could have break down this shape into simple triangles and rectangles. So it was also possible that you were calculating the area of this triangle individually, you were calculating the area of this triangle individually and this rectangle individually, and adding all the areas together to give you the total distance. That can also be done, whichever way you find it more convenient. The other thing that is asked in speed time graph is calculating average speed. So remember that average speed is total distance over total time. Okay, so total distance over total time. So in a graph, if a car has stopped for some break, you know that you are not covering any distance, but the time is running out. So you will accommodate that time. Also, you will take that stopping time into your calculation while calculating the average speed. So remember, this average speed is total distance over total time. Now we'll look at some questions. So in this question, we have been given a speed time graph for a car's journey. Let's try to understand what the graph represents. So since we have a straight line over here, this means that the car is accelerating uniformly, or it is moving with a constant acceleration for the first 15 seconds and reaches a speed of 20. Then it travels with a constant speed of 20 till k seconds, and then the car is decelerating uniformly and comes to stop at some time. You are being asked to find the speed when t is 12. Now remember, I just told you that the acceleration is same over here, is constant. So even if you take time value at 12 and try to figure out the gradient between these 2 points, the gradient between these 2 points would represent the acceleration, and acceleration between these 2 points is same as saying acceleration between these 2 points. So you can calculate the acceleration over here. Acceleration of the car from 0 to time t equals to 0 to t equals to 15 is same as the acceleration of the car from t equals to 0 to t equals to 12. So if you calculate the acceleration first, you will know that acceleration is 20. You can apply the gradient formula, 20 minus 0 over 15 minus 0. So you get 20 over 15, which is 1 so 5 times 4, 5 times 3, 4 over 3 meter per second square. Now using the same gradient or the same acceleration value, the same acceleration will also be between these 2 points. So I can fairly say that the acceleration between these 2 points would be, you want to calculate the speed at this point, okay? So let me call this as v. So v minus 0 over 12 minus 0, and the acceleration is going to be same, which is 4 over 3. And if you cross multiply, you can easily get the value of the velocity, which comes out to be 16 meter per second. So the value at time t equals to 12, the value of the speed at time t equals to 12 is 16. Okay. In the second part, in part B, you are being asked to find the distance traveled by the car from t equals to 0 to t equals to 15. So from t equals to 0 to t equals to 15, this is, in order to find the distance, I have to look at the area under this graph, under this curve, under this straight line. So this is in the shape of a triangle, so I can easily calculate the area of the triangle. So I can say that distance traveled by the car from t equals to 0 to 15 is half times 15 times 20, which is just the area of the triangle, and I can find the value now, which is 150 meter. So 150 meter is the distance traveled by the car from t equals to 0 to t equals to 15. In part C, I have been asked to calculate the distance traveled by the car from t equals to 0 to t equals to k. Okay, so the distance is given to you as 750. So you have been given the total distance from t equals to 0 to t equals to k, which means this entire distance. This region comprises of a triangle and a rectangle. So if I were to write total distance comprises of this area 1 and this area 2. Total distance is given to me as 750 meter. Area 1, which was a triangle, is 150. Area 2 is a rectangle. So if I try to find this length in terms of k, this would be k minus 15, this length, and the height is 20. So since it's a rectangle, the area would be length times breadth, k minus 15 times 20. Okay, if you try to resolve this equation and solve for k, you can get the value of k, and I get this value as 45. Moving on, the question says that the retardation of the car is 2 meter per second square, which means that the gradient of this car is 2 meter per second square. Find the number of seconds it takes to slow down and stop, which means I know that the car is stopping at this time. I am interested in finding the time it takes by the car for stopping. So this is the time duration that it takes for stopping. So let's find out the value of the time. Let's find when does the car actually stops in terms of time. So I have been given the retardation. Retardation is same as saying deceleration, and in this case the acceleration is -2. Acceleration is -2 meter per second square. Retardation is same as saying deceleration, and deceleration is negative of acceleration. Now if I were to take out the gradient at these 2 points, acceleration at this stage would be 0 minus 20 over, let me call this as t minus the value of k, which is now 45. This is equals to -2, and if you cross multiply and figure out the value of time, you must get 55 seconds. So the car actually stops at t equals to 55. The question is saying find the number of seconds it takes to slow down and stop. So the duration it takes to slow down and stop would be 55 minus 45, which is 10 seconds. Let's look at another example of a speed time graph. In this speed time graph, we have been given this speed time graph is for car A, and this car initially accelerates for 10 seconds, reaching a velocity of 15, and then it travels with the same constant velocity until the time which we don't know yet. Okay, now in the first part we have been asked to find the acceleration of the car A when t was 7. So I have to find the acceleration of the car when t is 7. So 7 would be somewhere here. Okay, now I don't know what velocity it is, and I have not been asked to find the velocity. I have been asked to find the acceleration. And remember, acceleration of a straight line will always be constant. Since it's a straight line, the acceleration will be constant. So it really doesn't matter whether I find the acceleration between these 2 points or these 2 points. So acceleration at t equals to 7 would be the same as acceleration at t equals to 10. So in simple words, the acceleration would be 15 minus 0 over 10 minus 0, which is 1.5 meter per second square. In the second part, you have to find an expression in terms of k for the distance moved by car A between t equals to 0 and t equals to k. So as we know that the distance can be obtained from a speed time graph by calculating the area under the speed time graph. So for car A, from t equals to 0 to t equals to k is this distance that we are interested in, the distance under the graph. Now as you can see, it comprises of, either you can take it as a trapezium or you can divide the shape into two halves, calling this as a separate triangle and that as a separate rectangle. It's up to you. I'll just break it into two steps. So I'll take this as area 1, which is a triangle, and this as area 2, which is a rectangle. So if I were to make an expression for the total distance, I'll have to calculate the area 1 as well as area 2. Area 1 can be calculated by the triangle area formula, which is half times base times height, and area 2 can be calculated in terms of k because we don't know the value of k yet. So this distance is k minus 10 and the height is 15. So yeah, k minus 10 times 15. Now you can simplify this further. 15k minus 150, and you should be able to get 15k minus 75. This is the expression for the total distance traveled by car A from t equals to 0 to t equals to k. In part C, the question says car B travels at a constant speed of 12 meters per second in the same direction as car A. On the diagram, sketch the distance speed time graph for car B. Now we know that the car is moving with a constant speed, and constant speed would be represented by a horizontal line. So at t equals to 0, the speed of car B was 12. So 12 value is somewhere here. Okay, and it continues to move at the same constant speed of 12. So you will have to draw a horizontal line over here. This is the speed time graph for car B. It's moving at 12 meters per second. Now when t is 0, car B passes car A. I'm doing part 2 now. When t is 0, car B passes car A, and when t is equal to k, car A overtakes car B. Now you need to understand this thing, that whenever overtaking takes place, the distance covered by both the cars would be same and the time would be same. The time of overtaking and the distance overtaken would be the same for both the cars. So when this overtaking takes place at k, I can say that the distance covered by car A is same as distance covered by car B. Now I already know the distance covered by car A in terms of k. Okay, so in terms of k, the total distance covered by car is 15k minus 75, and you already know how I got this distance expression, by taking the area under the car A graph. For car B, the distance covered by car B will be the area under the car B graph, which means that if this is the rectangle being formed for car B, and the total distance covered by car B can be determined by taking the distance under this graph. So I can easily calculate the distance for car B, that is the area of the rectangle, that is 12. Okay, this over here is k and the height is 12. So distance into length into width, 12k. So 12k, 15k minus 75 you can solve for k and figure out the value of k to be 25. I hope this video was helpful for you. Good luck.